Hello and welcome back to Pre-Calculus. We're going to work on the lecture with notes titled Transformations, Domain and Range Video Notes. We're going to continue to understand and apply the terms domain and range, but we're going to apply them to some non-parent functions. There's going to be some graphs that we see that don't have equations that go with them, but domain and range are affected by transformations of those. We start with three parent functions. We'll start with a parabola first. We're going to ask the question, does the following transformation of f of x change the domain only, the range only, both, or neither? And this graph, you may be familiar with, looks something like this. Looks like a U that opens up. Its domain goes from negative infinity to infinity, which means you can put any value into the function. However, because it squares, all negatives would become positive. And so the range will start at 0 but go all the way up, inclusive of 0. And what we're going to do is put a negative out in front. When we put an operation like an add, subtract, multiply, or divide outside of a function, it affects it vertically. In this case, a negative is a reflection. What that does is it takes all of these outputs and changes their sign. Or if they're positive, they're negative. And if the original is negative, then it becomes positive. In this case, our graph has all positive outputs, making the transformation give all negative outputs. In this case, the domain does not change. We can still put all values back in. The range has a maximum value of 0, and it goes down to negative infinity. Remember to write that as negative infinity up to 0. We always put the smaller number first. And if we check our answers, we see that the domain is unchanged, but the range now has changed. So only the range is going to change here. Moving on to the next parent function we've seen, it's a square root function, has a basic graph like this. When we do a transformation inside the function, it's going to be horizontal, and in this case, as you saw in the previous lesson, it looks like something that's the opposite of what you might intuitively think. For instance, if you add 6 to an x, you think it's going to move to the right. Turns out it moves to the left. So in this case, we would translate it left 6, all the x coordinates, and then on the y coordinate, since that's occurring outside of the function, it will be up 3. So we'll move 1, 2, 3, 4, 5, 6, 1, 2, 3, and put our new starting point and sketch the graph. Let's look at our domain and range again. The parent function goes from 0 to infinity for domain and range. Our transformation now caused the domain to become a little bit larger. It starts at negative 6 instead of 0 and goes all the way up to infinity. And the range doesn't get down to 0. It starts at 3 and goes to infinity. As you can see, the domain and range both changed here. So we would say that they both have changed. Moving on to the next example. Actually, let's discuss a little bit. In the previous example, we had a translation left 6, but the function had an x plus 6 in the function. And some kids get confused on why that is. It's a good question. The book on page 18 discusses some of the algebraic reasons for that. So if you want to take a moment, you can take a look at that and we can follow up in class with some questions. Moving on, the last one we'll do that's a parent function is f of x equals 10 to the x. As you may recall from a previous lesson, that function will graph something like that. When we do a minus 2 inside, it's going to be a horizontal and to the right 2, horizontal transformation. So we could draw a dashed line at x equals 2 making sure to get that point in, and then it's shifted to the right. Let's look at our domains and range. The domain, all values are able to be put in. The range, however, approaches a lower limit of 0. We call that a horizontal asymptote. So the smallest that our function gets is 0, and that's not inclusive. It doesn't actually get there, and it goes up to infinity. When we look at the domain and range of our transformation, the inputs haven't changed. You still can put anything in. And the range doesn't change either. Where these values occur has changed, but overall you get the same set of values that can be output from the function. So in this case, they're the same, and the range is the same. So neither has changed. Make sure I answered the previous question. Yep. All right, let's move on to some graphs. The graph of h of x could look like this 2-line segment, 3-pointed shape. I've put the coordinates in there. And if we want to change it by adding 2 to the outputs, what's going to happen is you will see a vertical translation, because it's plus, up 2. That's a bit redundant. I always start my transformations by stating horizontal or vertical, and then say what happens from there. Obviously, you could just say up 2 as well. What this does is takes all of our y coordinates and adds 2. So we're going to have a point at 2, 2. We're going to have a point at -1, 5. And we're going to have a point at -4, 0. Connect those dots, and we've simply taken this shape and moved it up. All right. The next one looks real similar. Since it's inside the function, we're going to say it's a horizontal translation. And again, remember opposite, or at least intuitively opposite. If it's +2, you might think it's going to the right, but actually this horizontal translation will be left 2 units. I think we can all tell that if we move this shape to the left, the critical points are going to be as shown here in blue. And if we connect the dots, we get the same shape moved to the left. All right. Now a reflection. For time's sake, I'll just explain what's happening here. The negative outside makes it a vertical. It's a reflection over the x-axis. A way to think about that for this set of points that makes this graph is to simply change the sign of y coordinates. Positive values of y become negative and vice versa. Of course, 0 stays on the axis, and we would get this shape. If we put the negative inside, we would say it's a horizontal reflection over the y-axis. We get that by taking all the x values and changing their sign. Hopefully I've put those where they need to be. 4 units over. You can notice that this spot on the y-axis is the same y-coordinate there for the original function and the transform function. All right. Again, to save some time, here's the graph of a parent function that is transformed as shown. It's vertical because the 2 is outside, the stretch because it's being multiplied. Essentially, you can take all the y coordinates, double them, and plot those points and connect the dots. It will become a stretch away from the x-axis. Verbally, we would say that this transformation is essentially the same. In fact, I'm going to show how much the same. I'm just going to grab all this stuff and go paste it to this slide. But I got to change a couple of details here. Instead of a vertical stretch, it's going to be a horizontal shrink. And you could say a shrink factor of 2. I say a half just so I think in my mind to multiply by a half each of the x-coordinates. X-coordinate on the far right is a 2. Half of it is 1. I'll put a dot there. X-coordinate on the middle point is -1. So its x-coordinate is going to be at -1/2. Y-coordinate doesn't change. And then the left side is going to have an x-coordinate -2. There you go. And if you look at it, in this case, the points have shrunk into the y-axis. We're going to take a moment on this one. This one's a little more complicated than it might appear. Obviously, there's more transformations happening. Even though they're all vertical, we have to think about the order that we do our transformations. So when we do these, if you think about PEMDAS, PEMDAS requires that we do multiplication or division first and then addition or subtraction. Similarly, if you think about a 2 being multiplied or even a negative being like a times -1, that would imply we should do those transformations first, the stretches or shrinks and reflections, and then the +1 out there would be added on after the stretch and shrink and reflections have been done. So verbally, these are all vertical reflections, or vertical transformation, sorry. It is a vertical, and I'm just going to write vertical once, stretch by a factor of 2, a vertical reflection over the x-axis. And then finally we will do a vertical translation up 1. All right. I'm going to use a green marker for an intermediate step. I'm going to do these 2 at once, and then I'm going to translate the whole graph up 1, or each of the points to start with. So if I stretch by a factor of 2, I'm going to take a 0, turn it into a 0, because 2 times 0 is 0, and then make it negative, no change. I take the y-coordinate of +3, double it, 1, 2, 3, it goes there, and then reflect it down to 6, 1, 2, 3, 4, 5, 6, so down at -6. And then -2 doubled goes down to -4, reflected up to +4. Another way to think about that, if you wanted to take a bit of a shortcut, you could just multiply by -2 and you'd get the same y-coordinate. Now I'm not going to connect the dots yet because I still have one more transformation left. It's a translation up. That's a pretty easy one. I just add 1 to each of my points. And I'll get rid of the greens. Connecting these dots gives me my transformation. We're going to skip this one as a lecture, but all the work's been done. Again, the green is an intermediate step, and I've stated verbally what would happen. Notice that this has a horizontal shrink by a 1/4. You could say 4 if you wanted, but the point is make sure you take the x-coordinates and multiply by a 1/4 or divide by 4. That is the end of the lesson. Look forward to seeing you in class.